Welcome back, y'all. We are on analysis of two quantitative variables. We're doing the R project for that today. One thing that I want to highlight to you is when you take your exam for this set of material, this R project is going to be a very close reflection of the type of thing that you'll have to do for the exam. So make sure you understand things. If you don't, reach out. Okay, so just like normal, we're going to go to shared projects and then Bergaker and 215. And we're going analysis of two quantitative variables. Remember to check the box. And then I'm going to go copy two. I'm going to go to my 215 folder in my home location. Click save. Then I'm going to go back home, back to my 215 and open that analysis of two quantitative variables. All right, make sure you work from the top down. So change your name and today's date. And then we're going to run the library. Remember, if you get red when you run the library, that's fine. Just telling you what it attached. And then we want to run the whole data chunk. So instead of just highlighting that, I'm going to push that green triangle over on the right-hand side. And then I have my data read in. So you should see IQ. If you also see other data sets that we worked with in the past, that's fine. You just need to at least see IQ. Now you see that I have toggled so I can see what the data names are. This is going to be important this week because these are not capitalized and that's different than the data we've been working with. So we have to remember to do it exactly the way that it's written here. All right, so if you don't have your Word document open, I would recommend that you do that. And what we're looking for today is to see if people who have a higher IQ would have a higher GPA. So we have to decide on what the explanatory variable is and what the response variable is. One of the things that I want you to notice in the Word document is it says one would think that having a higher IQ would result in a higher GPA. When it says that, it's talking about the direction that the relationship is expected to have. So it's expecting that IQ results in something about GPA. So that means that IQ is our explanatory variable and GPA is our response. So now we know how to fill out all of these pieces of code. So we're going to start with our data. So we have IQ, and since I have it copied right now, I'm going to change all of them. And then our response variable, remember, is GPA. And we can see over here in the environment window that that's in all lowercase. So I'm going to write GPA. And just like I did with the IQ, I'm going to copy that and I'm going to paste it in all of these just because it's quicker to do it that way. And then you also can see over here the IQ as a variable name. This isn't our data, so as a variable name is in lowercase. So we have lowercase IQ. And I'm going to copy that. And again, that's going to be my explanatory for the whole project. So I'm just going to paste that. All right. Now we should write our legend title. Maybe we would say IQ impact on GPA. Something like that. All right. I'm going to run that scatter plot. You can see that nice scatter plot show up. It's got IQ on the x-axis because that's the explanatory variable, and then GPA is the response, and so it's on the y-axis. I don't know where I got this data because the GPA is like from 0 to 10. It's very odd. I don't know about that. Anyway, you'll have some questions in your Blackboard document that asks about the pattern. So how strong it is or how weak it is, if it's linear, if it's positive or negative. So I'll let you all answer those. And then starting on question 6 and 7, we'll want this next line of code to get the correlation coefficient, or R. If you click in on it, it stops being gray. I don't know why it starts that way, but this is the correlation coefficient, or R, at the end. So 0.634 is our correlation coefficient. Now, remember that the closer you are to 1 or -1, the stronger it is. So this is not weak, but it also isn't very strong. I would say it's got a moderate strength since it's more in that middle portion. so that will help you answer question 6 and 7. Question 8 has the r squared, and so you'll actually have to take that 0.634 and square it because it's not given on the table. And that's easy enough to do for question 8. All right, question 9. So we need this line in line 37, my line 37, to get the linear regression or the regression equation. So these are easy to read. You want always the estimate column, and then the y-intercept is next to the word intercept, and then the slope is next to the x variable. So when you write this out, it would be y hat equals, and then you would have negative 3.557 plus, because this is positive, plus 0.101x. That's how you would write that regression equation. So you read it from the estimate line or column, and then intercept has the y-intercept next to it, and then the x variable has the slope next to it. All right, then the last thing, so that helps you do question 9 and 10, and when you interpret the slope, remember it's as the x variable increases 1 unit, and here the unit is point, so as IQ increases 1 point, we expect, and then you would state how you expect the slope to change the GPA. Okay, then the last one, we want to see if there's a difference in what time of the year people were born, and that variable is born for their IQ versus GPA. So IQ impact on GPA for different birth times. So I'll just say it like that. All right, we're going to run that. So now you can see that we have the first half of the year is kind of in that purple color, and the second half is yellow. So when you're comparing those here, I wouldn't say that there's a difference. Yes, maybe the second half is a little bit lower, but these are not a very tight pattern. Up here you see they're scattered throughout, so I would say there's no difference between the time of year that someone was born for their IQ versus GPA. Like, one doesn't have a stronger relationship than the other. All right. Last, I want to give you a hint about number 12 and 13. So 12, you're going to use that regression equation that I just mentioned, and you're going to plug 100 in for x. When you get to 13, that is going to tell you what the y is. So remember, when you calculate a residual, it's y minus y hat. So it tells you the y, and you would subtract the result of question 12 to get the residual. All right. And I think you can do the rest. So if you have any questions, let me know. Otherwise, knit when you're done. And this week it's set to knit as a Word document, so you shouldn't have any issues with latex errors. And please be sure to also upload it into question 16, but then also the additional content. It just makes it easier for me to grade. All right, happy coding.